Good morning, grade 8. We are now down to Q3 or third quarter, weeks 1 to 4. Okay. But apparently I opened the weeks 5 to 8 for Q2. So those who are not done with the second quarter, weeks 5 to 8, you may so do your activity. It's in there already, it's open. At the same time, all the activities for Q3, third quarter, for weeks 1 to 4, okay, is all open with no restriction at all. Just make it sure that you are done. Just make it sure that you are doing all your activities. By the way, with regards to the activities, all of the activities there are lesson. If you're going to check on the module itself, those are shortened, those are precise. That's one way to help you out. That's, for me, it's one way to help you out. All right. Let's move now to properties of matter. Okay. In this module, we will learn what are the different properties of matter, how these actually applies in our daily lives. What else? How we are affected with this. Okay, the properties of matter. What are the benefits that we can get? What are the uses of this? And how can we maximize these properties? Right? Let's move forward. I can only see 2 students here, Victor Gabriel and Greg Ramirez. States of matter. Okay. States of matter, we have solid, liquid, gas. Let's start with gas. Okay. Do you agree with the statement we live in an ocean of gases? The gases refers to or referred to as is the atmosphere. Okay. The atmosphere is a thin veil between us and the outer space. Atmospheric gases support life on Earth. Okay. What is the most essential gas? Okay. What is the most essential gas that is beneficial to all living organisms? What do you think so? Anybody?
Oxygen.
Oxygen, correct. Okay. If you're going to look at, thank you, Victor. If you're going to look at oxygen, it's only 21% of the atmospheric gases. Meaning to say that this is a limited. This is a limited supply. It is not unlimited. And it has a limited also, what? Sources. Sure. Why do you think so? It's a limited sources. Remember that these are the byproduct. Oxygen is a byproduct of photosynthesis. Okay. Who are or what organisms can actually produce oxygen? What organisms can produce oxygen since this is a byproduct of photosynthesis? Anybody?
Plants.
Plants, correct. That's the primary. Plants. So only plants and photosynthetic organisms can actually produce oxygen because this is a byproduct of photosynthesis. That's the reason behind. Okay, without these organisms, without these autotrophs, the producers, there is no oxygen at all. Okay, and without those photosynthetic bacteria and photosynthetic protozoans, we don't have oxygen. Okay, other gases like carbon dioxide, Earth's atmosphere consists of nitrogen, which is 78%. This is the reason why there are nitrogen fixing bacteria, okay, in your beans that actually fix nitrogen because they cannot use this one, okay, in a gas form. It should be converted into nitrites and nitrates in order for the plants to use nitrogen. Oxygen, which is 21%, okay, and other gases like carbon dioxide, water vapor, argon, helium, xenon, neon, and krypton. A gas exhibits the following characteristic or characteristic properties. We have, it has, number one, it has no definite shape and volume. It's a gas. It diffuses easily. Like, for example, if you are cooking, okay, if you are cooking, the smell, the fragrance of the one that you are actually cooking will just what? Diffuse in air. Okay? That's the property of a gas. It flows. Correct. It can be compressed, just like your tires. Okay? It is a compressed gas. Okay? And it exerts pressure, just like your pump, air pumps. It exerts pressure. Okay? The characteristic behavior of gases can be explained by the kinetic molecular theory of a matter, the KMT. Okay, we'll discuss KMT, hopefully, in this module. Okay, the term kinetic means motion, right? According to KMT, gas particles are considered to be very small and have negligible volume and are far apart from each other. They're really far apart. A gas is mostly empty space. Okay, there is an invisible attraction or attractive forces or force existing between gas particles. This attractive forces is called the intermolecular force. Okay, again, please take note of the terminology. That's intermolecular force. A gas particle are at constant and chaotic motion. Chaotic meaning it's moving. These moving particles may be in atoms, or maybe atoms or molecules. A molecule is a group of two or more atoms held together by a chemical force. Okay. Another assumption of kinetic molecular theory or kinetic theory is that the average kinetic energy of molecules is proportional to its absolute temperature. Again, the average kinetic energy of molecules is proportional or directly proportional to its absolute temperature. Okay. Average kinetic energy over absolute temperature. Okay. This means that the temperature goes higher, or this means that as the temperature goes higher, magkataas ang temperature, the molecules move faster. Okay, and as temperature goes lower, the molecules move slower because they are directly proportional. Diffusion. Okay, since very negligible intermolecular force exists between molecules, gases fill their container regardless of their shape and volume. And contained gas diffuses into every available space. Okay, just like where you're actually staying. It is composed of different gases there. This explains why you can smell adobo all throughout the kitchen because it actually diffuses all throughout. This also explains why gases do not have definite shape and volume because, again, it diffuses, its container diffuses directly to a certain area. Compression. It can be compressed. Correct. Gas molecules are very far from one another. Between the molecules are empty spaces. Because of these empty spaces, we can actually compress them to exert pressure. This explains why gas may be compressed because there are a lot of empty spaces all throughout their area. Okay, they're very far from one another. Pressure. Pressure is defined as force exerted per unit area. Okay. Gas pressure is a result of simultaneous collision of gas molecules with one another or with an object. Remember that gas is very far from one another. So if you're going to put them together in a closed container, you're now creating a force or a pressure inside the container. Barometer is an instrument to measure atmospheric pressure. A falling barometer signifies the decreasing air pressure, and a rising barometer signifies increasing air pressure. Do you have any question with gas? Question
sir.
with gas? Hi, Keisha. By the way, how is everybody doing?
Fine.
That's great.
Good.
Actually, I'm happy to see some of your classmates, some of you having the online class. I am actually worried with other students actually, but hopefully we can recover. This is the reason behind why I listen all the lesson, all the activities. If you're going to check on your LMS, you're going to check on your modules, it has less activities. Take note. I am doing the module for weeks 1 to 4. That's the entire month if you're going to look at it. But it has fewer activity because I'm still thinking about you're still recovering. We are still recovering with a certain situation. And hopefully we can cope up with this. I am discussing this little by little in order for us to understand and of course upload it in the LMS. Again, in the gas, it has these characteristics. Number one, it has no definite shape and volume. That is why it can actually can actually fit to any container or any container that it contains. Okay. Aside from that, it diffuses easily. This is the reason why when you spray your perfume in your room, it will eventually go to the other area in your house because again gas diffuses easily. It flows. This is the reason why we can actually transfer, like for example, transfer oxygen from a tank to another tank. Okay, it can be compressed. This is the reason why it can be compressed because if you're going to look at the intermolecular forces there, the arrangement of the atoms and the molecules of gas, it has a lot of spaces. Okay, these spaces can be filled up with another molecule. So if you're going to put them together, you are now creating pressure. So it can actually exert pressure. Okay. Questions with gas? Questions with gas?
No, sir.
Right. Let's move now to liquids. Okay. It has the ability to flow. Same as your gas. Like gases, liquids are referred to as fluids. A liquid may be poured from one container to another. Okay, weak attractive forces hold the liquid molecules, yet allow them to move and slide past one another. This explains why liquids have no definite shape. It has no definite shape. It depends upon your container. Viscosity is the resistance to flow. Viscose. Okay, the vernacular term for viscose is lapot. Viscosity, viscose. Okay. Diffusion. The particle of liquids move around each other. This characteristic is responsible for diffusion in liquids. Okay. Surface tension. By the way, for diffusion, since these molecules, the particles are moving, it can actually diffuse from one fluid or from one liquid to another. It depends upon. You remember the density? Okay. If a liquid has different density tendencies, you cannot actually mix them all. Why? Because the other will float and the other will submerge. One good example is your oil and your water. You cannot mix oil and water. Why? Because they have different densities. Let's take a look at that one later. Surface tension. Okay, surface tension is defined as the force on the surface in the liquid that makes up the surface area as small as possible. Okay, surface tension allows needles, take note, paper clips, and razor blades to float on water if placed carefully in the surface. It also explains why drops of water are spherical in shape. Have you seen a droplet of water? Everybody, are you still with me?
Not yet, sir.
You can actually observe droplets of water. Now, when you go outside your house, okay, check your plants. Okay, you can actually see them usually on the tip of a leaf blade. Yeah, that's the product of transpiration. So you can actually see some droplets there. It is spherical in shape. This is the reason why, because that is because of the surface tension. Your needles also, have you tried placing a needle, carefully placing a needle in the water? A needle can actually float because of surface tension. Okay. Some insects and some animals also has the capability of surface tension. Okay? Sure, what happened to that? Remember that your liquid, okay, has forces also. Okay? These forces is continuously moving. Okay? And these forces also allows surface tension to happen. Capillary action. Supposed to be we will have an activity of this, the laboratory actually. But of course, still we are in the pandemic situation, we cannot do the activity. Capillary action results from the competition between cohesive forces, the intermolecular forces within the liquid, and the adhesive forces, the forces between different substances like water and glass. Okay? The relative strength of adhesive forces and cohesive forces explain why the meniscus may curve up like in water and curve down like in mercury. Meniscus is a convex on or concave surface of a column of a liquid. Capillary action explains also the absorbing property of paper towel and cotton. Are you familiar with meniscus? Meniscus, like I think I have it here. Wait. Okay. If this is your container, okay, have you seen this circle one? This one? Are you still with me?
Yes, sir.
Everyone is okay. This is what we call as meniscus, spherical in form. Okay. If you're going to observe this one, this is highly observable in test tubes. Okay. If you put liquid on the test tube, you can observe this one. Okay. This is the lower meniscus, and this is the upper meniscus. Usually, when we have a check on the volume of a particular liquid, okay, you usually have the measurement here, the lower meniscus. Okay, this is the meniscus, okay? Go back to capillary action, okay. Again, this is the result between intermolecular forces and, of course, the forces between substances, adhesive and cohesive, okay? So again, capillary action explains the absorbing property of paper towel and cotton because they have different, what? Intermolecular forces. And again, the movement of this fluid is from greater concentration to lesser concentration. Okay? So like for example, if you're going to transfer water using a paper towel, okay, from greater concentration, it will be transferred to the another container to the lesser concentration until such time that they will actually exert equal volume of water. Sure, how about the capillary action with colors? Let's take a look at this. Okay, these are the same. Okay, you're going to look at this experiment. These are the same plants. Okay, but as you can see, it absorbs color. Okay, how would that be possible? Have you tried this one? Okay, transferring color to a plant. This is one of the experiment in capillary action. Are you still with me?
Yes.
Okay. The reason behind, okay, the reason behind why these, okay, these color pigments are carried by plants, this is because of capillary action. This is actually capillary action. Okay, what happened here is that plants has xylem and phloem. Okay, the xylem carries, again, the xylem carries water and other minerals towards the upper part of the plant. Okay, so it carries the minerals and other supplements towards the upper part of the plant. Okay? Against gravity. This is against gravity. Right? And the phloem distributes the different nutrients created by the plants, starch, and so on. So meaning to say, this capillary action is actually what? Carried by xylem. Okay? This is the tubes in the plant. As you can see, colors are being absorbed by the plant and distributed all throughout the different parts of the plant. Vaporizing or evaporation. Okay. Evaporation and vaporizing or vaporization is the transformation of liquid into gas. Okay. Another term for evaporation is vaporization. Okay, vape. Okay. Evaporation takes place at the surface of the liquid. The process occurs faster at the volume point or the boiling point. Boiling point is the temperature at which the vapor pressure of the liquid is equal to its external pressure. So, tendency is it will actually boil. A particular liquid will actually boil. Sure. Does different liquids has different boiling points? The answer is yes. Boiling point of water is 100 degrees Celsius or centigrade. The rest still different. It has a different boiling point. It depends upon a particular liquid. Okay. Vapor pressure is less than the atmospheric pressure. Bubbles cannot form. But vapor pressure is equal to its atmospheric pressure. Bubbles can form and rise. Okay, that's the difference. Do you have any question with liquid? Let's move now to solids. What's in the solid? Okay, these are the properties we have: incompressible, okay, rigid, hard, and compact. Okay, solids are nearly incompressible. It cannot be or not compressible, or can be slightly compressed, but that is not a property of a solid actually. This is slightly compressed, rigid, and compact because strong attractive forces hold the particles. Okay? They do not flow. Solids do not flow. Solid particles, in contrast to liquid particles, only vibrate at fixed positions. They do not slip and slide to fill the container. Hence, they do not flow. Two types of solid structures we have. Crystalline solids have defined shape. Their particles and atom molecules or ions occur in highly ordered arrangement. Some crystalline solid can exist in various forms. These crystalline solids are called allotrophs. Okay. These are the major types of crystalline solids. We have the atomic, okay, the molecular, the ionic, the metallic, and the network. Okay. If you're going to look at them, it has a different behavior. It has a different interparticle forces, and of course, different melting point. Okay. It's okay. It's okay. It's okay, Victor. Another form of your solids in crystalline form are your birthstones. Okay. We have garnet, amethyst, aquamarine, diamond, which is diamond sapphire, okay, emerald, alexandrite, ruby, peridot, sapphire, opal, citrine or citrine, zircon. So these are the examples of your crystalline solid. It has a definite, it has a precise shape. On the other hand, amorphous solids are non-crystalline solids. Examples are charcoal, okay, rubber, and glass. Amorphous carbon, that is charcoal produced by destructive distillation of wood. Okay, another form of amorphous solid is carbon black, a powdery soot formed from the incomplete combustion of natural gas. Okay, carbon black is used as pigment in printing inks and in carbon paper, typewriter ribbons, photocopying machines, and etc. If carbon black is heated to 800 degrees Celsius to 1000 degrees Celsius, you can actually create activated carbon. Okay, it is highly porous and like sponges or honeycombs. It has high absorptive property and it is used in masks and water filters. It also helps remove colors and odors of some industrial processes. Powdery soot formed in complete combustion of natural gas. Just like if you're going to use wood in cooking, okay, you can observe this one in your utensils, in your the materials that you are actually using in cooking. Okay, the one black, no, these are the incomplete combustion of natural gas. Okay, that's carbon black. Do you have any questions so far? Do you have any questions so far? Everybody, can you hear me? Okay. I think we had discussed much, and let's continue by next meeting, hopefully. Thank you for your participation, Greg Ramirez, Keisha Cueva, Victor Gabriel. Right? Hopefully your other classmates can join by next meeting. Please inform them that this will be uploaded in the LMS, and of course, they can always check on them. Right? Your major exam is fast approaching, your third mastery test, and your third periodical tests. This is included in your third mastery test and periodical test, right? Have a nice day, grade 8. Take care. Hope to see you soon. Bye-bye. Have your lunch.
Bye.